Okay, hello and welcome to another virtual jug session, and this is actually really going to be a very, very fun and interesting session. One that a style that we've not done before. This is an Ask Me Anything. So this is where we have huge audience participation, and we grill many Java experts, such as the fine fellow sitting next to me in the UK, all the way from Colorado. How are you doing, Venkat? A pleasure to be here. Thanks. That's our pleasure. Certainly, this is maybe, well, apart from the book reading club, maybe your third time on the virtual jug. That's great. Yeah, well, welcome.
Thank you.
Why don't you give a brief intro as to who you are?
Sure. Venkat Subramaniam, programmer, author, just somebody who loves, coding and talking about coding.
Awesome. Nice. And who have we got online? And we have currently we have we originally had both Simon Ritter, Stuart Marks, and Yara Senger, but unfortunately Yara had something come up right at the last minute, so we're hoping to get maybe Bruno on to represent the community, but we'll see if that happens or not. So let's say hello to let's keep it in the UK while we're in the UK. Let's pop over to Simon Ritter. How you doing, Simon?
I'm doing well. I have a beer. Yeah, so to introduce myself, yes, I'm Simon Ritter, ex of Oracle, now at Azul as Deputy CTO. And still doing pretty much the same job as I did before.
Awesome, cool. And all the way over to California, how are you doing, Stuart?
Very good, thank you. Hi, I'm Stuart Marks. I work at Oracle. I'm sitting in sunny California right now. It's a warm February day, and I'm looking out at blue sky with very few clouds. So I'm at Oracle. I work on the JDK core libraries. I'm a developer, core developer on OpenJDK as well.
Awesome. So in terms of the panel, then I'll be kind of moderating, making sure people don't speak for too long. Keeping the conversation moving, making sure we cover a good range of topics. In terms of the panel, then we have, let's say, we have our Oracle guru expert in terms of Simon. Sorry, Stuart. we also have an expert from another Java vendor, of course, from Azul, in Mr. Ritter. And we have someone, I always said I wanted someone from Oracle, someone from another company that produced a JVM, someone from the community, and someone from the Venkat category. And unfortunately, there's only one person in the Venkat category.
He's in a class by himself.
Absolutely. So we've got a really nice kind of mix of different backgrounds here. I'm actually going to start off with a question, jumping into Java 8 Lambdas. I'm going to jump straight into IRC. Blue61 on IRC says, "Okay, here's my question. With Java 8, there has been intelligent deducing of types for lambdas introduced in the compiler. Is there any other use of it apart from defining lambdas?" And this is something that's really big. I know you talk about many different JVM languages. Loads of JVM languages do that kind of type inference, right, where whatever's on the right-hand side, the compiler deduces that type and makes whatever is on the left-hand side, just makes it, that type. Why do we not have that in Java? How useful is it?
Well, my real desire for having type inferences, it's a lack of ceremony more than anything else. You know exactly what the type is. The compiler knows what the type is. Why waste your time and effort saying it? So I like it from the point of view of lack of ceremony. For example, when it comes to static typing, I really didn't like static typing until I started programming with Haskell. And what I was really fascinated by Haskell is it is statically typed, but very rarely you have to actually say the type. It intelligently infers the type for the most part. Mm-hmm. So I see it mainly as a lack of ceremony, more expressive without standing in your way. In Java, we are used to giving type almost every corner we turn, but with lambdas, we don't have to for the most part. It's not true all the time. So I'm actually in favor. When it comes to C#, I prefer using var rather than specifying the type. In Scala, I rarely specify the type. I let the language infer it. Same thing with Haskell. So I'm actually in favor, except exactly for the lack of ceremony.
And this is still static typing, right?
Oh, absolutely, all the way through.
We're not expecting. It's not like by the time we only realise what the type of that variable is going to be at runtime. We know it.
Well, you clearly get a compilation error with specific type inference. The language compiler says, "This is what I figured it is, and if you and I are not in agreement with it, let's resolve it now during compile time." It's not dynamic typing, so I'm all in favor of that.
We've heard from good cop. Let's go to bad cop. Stuart, why don't we have this in the JDK?
Well, all right. So people in various other languages, there's this, like in C# and Scala, there's this var or val declaration, and people refer to that as type inference. And they say, why doesn't Java have type inference? And Java does have lots of type inference going on. It's just that it's going on in a different place. And so, you know, I think it's a matter of language design style, but if you're going to declare a variable, then defining exactly what type it is, I think, is very useful. In particular, the typical way to declare a list is to say, you know, list of string X is, and then you separately from that either assign it or initialize it to something, but give it an implementation type that is different from the interface type that you declare the variable as. So there is lots of type inference going on in Java. It goes on in a different place, though, not at the type, but not at the type of a variable declaration. But the actual question was, is there any other use for it apart from lambdas? And it's like, and that's a little hard to say. I think it was the type inference that was added to Java 8 was focused on lambdas, so that you could write a lambda without defining. Without declaring large numbers of types, particularly for the parameter types and the return type of the lambda. And so you can see that I would say in at least 95% of cases, you do not have to write the types for any lambda expressions. And so that's where you really see type inference going on. I think there are other places where type inference occurs, particularly for generic for type parameters of generic methods. That's been in there a long time. It's been improved a lot in Java 8. But what's interesting is you don't see it that much. It's not manifest. But if you look at a lot of cases, the generic type parameters are actually being inferred for you. So.
And there's nothing new in Java 9, right? In typical as you would write your code to have method info.
I'm not aware of any work that's going on in Java 9 with regards to type inference, except for adjustments and bug fixing. No major features that I'm aware of. Quick aside, I noticed looks like Bruno has joined us.
Yeah, hey Bruno, can you hear us?
Hey everyone, I can hear you fine. I hope you can hear me.
Awesome, we can hear you. Let's have a quick intro into
there we are.
First of all, at late notice as well. Do you want to give us a quick intro to who you are and what you do? And you're here on this panel from a big community part of Java, from where I work.
Okay, so hi everyone. It's very good to see all of you here, and especially everyone that's watching us right now. You know, I'm known as the Brazilian Java man. I have been evangelizing Java since Java came out in 1995, and I'm also known as the guy with the flag. You know, the guy that walks around Java 1 with the Brazilian flag. And that's it. You know, I've been around, done Java since Java Alpha, and, you know, working on large projects, helping create some large Java user groups around the world. Today I'm the president of Azul Java, a very, very large Java user group here in Brazil. And that's it.
Awesome. Well, let's stick with you, Bruno. I want to ask you something. It's a great question. And this is from 3RP capital HA. I'm assuming that's a nick rather than their actual name. But is Java open source, or is it open specification?
So that is a very good question. There is, first of all, I think Java is it's many things, right? So it's sometimes a little bit confusing for us to define because really, if you go down to the details, Java is a trademark, right? It's a name that's owned by Oracle, and you have some rules on how you can use it. We also have funny things in the past where Sun decided to use the Java brand to weird things like Java Desktop, for example. It was a Linux desktop. It was called the Java Desktop. So it's in the end is a trademark. But Java is a language, and as a language, no language is really. It's protected by copyright, but you can't patent. So you can implement this language in different things. So as a language, Java is very free. But also Java is a specification, right? So it's defined by the JCP. It's the JSR 377. It's what defines Java 8, for example. So Java. Actually 337, I'm sorry. So JSR 337 is what defines the Java 8 specification. So Java is an open specification also, but also Java is a software, right? So it's this thing that you install in your computer. So that software you install in your computer can be an open source, and there is several implementations of the Java specification as open source. The most famous one and the most complete one is OpenJDK. So Java is also, there is also an open source implementation of Java. So yes, Java is a specification. Java is open source, and the interesting thing is there's lots of implementation of Java. But since Java is also a trademark, and you can just apply the trademark once you accept the rules of it, then the only way for you to call something Java is if you pass the TCK, the tests, right? So every time you develop an implementation of the Java specification, if you want to call it Java, you have to pass the TCK tests, right? So once you pass the TCK test, then you can call whatever you have as Java. That's why we have several implementations of the Java specifications, and several of those implementations have been certified and can be called Java, right? So I think that's where the confusion comes from, because it's like many different things. But I think in general, we can say yes, Java is an open spec because it's defined by an open process run by the JCP, the Java Community Process. Java is open source because there is an open source implementation, actually several, but there is a complete open source implementation of the Java specification, that is the OpenJDK, and that's it.
What about getting code into the OpenJDK? I'll ask Simon, as someone who's maybe seen this from the outside and inside. How easy is it for someone to actually just drop some code into the OpenJDK? Are there any barriers, or is it easy?
Okay, so I'm going to start by doing a politician thing, and I'm going to answer the previous question rather than the question you just asked. Yeah, so Bruno's absolutely right in what he says, but just to kind of clarify that a little bit, because I was actually involved in a lot of the stuff back in when Sun actually open sourced the JDK, and I remember being in some meetings and people were going, "Oh, you need to be very careful about what you say about this." It's because Java, as in the Java platform, has not been open sourced. Java, as in the JDK implementation from what was Sun and now is Oracle, has been open source. So that is the source code that you can download as part of the OpenJDK project. The specification, as Bruno rightly says, is an open specification which is created through the JCP and through various JSRs which define exactly what goes into that. OpenJDK provides an implementation of that which passes the TCK in order to qualify that it actually is that implementation. So having answered the previous question, I'll now answer the next question. Yeah, I mean, how easy is it to get code into the JDK? I must admit, I don't really have a lot of experience in this, but my understanding is that you need to go through, a qualification process to show that you are, reasonably competent in what you're doing in order to commit code. There is a lot of work going on in terms of adopt OpenJDK, which is the idea of getting people to work on some of the sort of, rather than big chunky bits of code and putting those into the source code base. It's more about correcting things like spelling errors and making sure the Java doc is correct and stuff like that, and little things that can kind of lead into getting more code into OpenJDK. So it is very much an open process, but in order to maintain the quality, you do need to go through a qualification process and make sure that you're actually the right person to be committing code.
So actually, Simon, this question is really interesting because when you think about how easy it is to get code in any project, right? you know, any project has a group of people that's working on it, and the larger and more important this project is, the more people that actually use this project. There's more, you know, checking and verifications and testing everything to actually get code into the project, right? So if you see the Linux kernel, for example, there's just a very tiny little bunch of people that actually work on this. If you see the Apache web server, you know, there is a core group that works on that. And so it's any large project, it's very hard for you to actually put code into it. So projects do make a lot of work to actually facilitate that. OpenJDK does have, you know, like Simon said about, you know, the adopted OpenJDK effort. There is a lot of initiatives to help and facilitate that. But yes, it is hard because, you know, you have to write good code that has to be revised by lots of people, that have to be accepted by several different people, because it's going to be used by millions of people, right? So it has its complexity to do that. Now, the interesting thing is, you don't need, you know, a lot of times you don't actually need to put code into the JDK or into OpenJDK to actually modify it, because, you know, if you download the source code for OpenJDK today and you modify it and you compile it and you run in your machine, for example, there is absolutely no problem at all. There's you know, you don't need to do any difficult thing, because you're just going to run your machine, right? If you want to distribute your friends, that's fine. If you want to clone that project and, you know, distribute to other people, that's also fine. You know, there's a lots of different ways for you to actually write code into OpenJDK. You know, we have been working at the JCP with the guys from Twitter, for example, and Twitter, they have internally they have their own build of OpenJDK that they maintain. You know, they download the source code, they change things that's needed for them, and they run internally. All fine, all easy. So it is easy for you to actually change the source code of the OpenJDK. Now, it's very hard for you to commit that code back and have 9 million people using it. So that's different.
Okay, cool. So let's jump into some more tech. I want to keep it code from here on in now. Let's talk about Lalwanis in IRC. It says Java 8's new feature functional programming is great, but he's noticing that, or she's noticing that the chaining with new functions can be confusing. And I'm guessing this is maybe stream related. Do you think it's confusing?
So this is one thing I talk about, the difference between familiar versus simple. And a lot of times, what we are not familiar with appears to be confusing and complex. But once we become familiar with it, it really becomes simple. So to give you an example, I was at a client site. I don't know anything about this particular client's domain or application. But the developer said, hey, would you please take a look at my code and tell me if I'm in the right direction? Now, usually that draws fear in me, because when I look at a code which is monstrous and confusing, I would have no clue what it's doing. But I sat down, this was a stream, and he starts speaking through the code saying, here's a collection of objects coming in, and since we are on camera, I can be specific about it. A collection of streams coming in. I'm looking at these sets of objects, only with these kinds of properties, doing these things. I'm reading through the code, and I'm saying, dude, this is what it's doing. And he's like, yeah. Well, the person who doesn't know anything about this, I'm able to communicate with him. Had this been a for loop with the if and a break, I would be really lost. So for somebody who is familiar with the functional style, it's extremely intuitive. But for somebody who is not familiar with functional style, it can be very confusing and intimidating. So the key is to get used to it, become familiar with it. It becomes much more. So the impedance is really less, but there's a barrier to entry we have to go through.
So understanding it in terms of just reading the code is probably easier.
Well, we need to definitely understand what filter and map and reduce means. Yeah. Then it becomes a lot easier.
How about understanding it in terms of, when we talked about this in the streams session, talking about it in terms of maybe debugging, since you get huge amounts of data through. Perhaps that's the confusing.
Sure. Well, I think the key is to see. This is one of the reasons why I really like the word stream, is because the developers of Java said this is not just a function composition. This is a very different semantics. You are dealing with a lazy evaluation. So when you get in, you need to know, putting a breakpoint, you're not going to hit it until you hit the terminal method. So learning the semantics of functional programming is very critical before we can debug. But that's kind of like saying, I want to debug multi-threaded code. well, we need to understand semantics in multi-threaded code as well. Otherwise, it becomes frustrating.
Okay.
So I think it gets easier once we understand semantics, but without it, it can be really confusing.
So perhaps that mindset.
It is.
I think so. Yeah. Anything coming in Java 9 to make any of this easier, or maybe do you think it needs to be easier, Stuart?
Well, I'm not too clear on exactly what's difficult about it. And I think Venkat covered some interesting points, which is unfamiliarity. And once you're familiar with the operations, then I think things do get easier. So I think that's a good point there. I think that there are some things that are conceptually difficult to understand, and I think that's really something that requires learning and education as opposed to changes to the platform. And in particular, I'm thinking people have difficulty with the concept of flat map. They get filter and map, which are pretty simple, but flat map is, I've seen, personally, I latched onto it immediately. I said, oh, I know exactly what that means. That's incredibly useful. But other people, not to fault them, I mean, it's a difficult concept, and so I think that might be some difficulty. The notion of reduction is a good one, especially associativity, right? It's very easy to say, oh, I can slam this function in here and it should work, and it doesn't, or it behaves differently in parallel. That's a common problem, and I think you really have to understand the fundamental concepts before, as opposed to expecting enhancements in the platform to deal with that. There are going to be some enhancements in streams, but they are mostly kind of minor things added to fill in the gaps. In particular, one thing that we have added in JDK 9 that many people found missing was take while and drop while, which are conditional. I would say conditional operations on ordered elements in the stream, and that's something that a lot of people miss from other functional programming systems. And so, but there again, we chose those terms because they're familiar to other people from other systems. But if you don't know what they do already, then you kind of have to look at it. And in fact, the documentation is rather difficult because it's a specification of exactly what occurs, and so it's kind of hard to understand if you're not familiar with it already. So I think we're going to be filling in additional operations in JDK 9, but I don't think that there are very many things that will make chaining fundamentally easier. I think there's some unfamiliarity that people have to get over, and some conceptual learning that has to occur in order to get over that.
Okay.
Yeah, if I can just jump in here just briefly. I kind of agree with Stuart in that a lot of it is fundamental in terms of shifting the way that you think. And one of the things I found with using streams, and Stuart will know this from the blogs that I've written and stuff we've discussed, is it's very easy to try and approach streams as an imperative programmer and try and kind of like force imperative programming into streams by using for each, which is not necessarily the right thing to do. And so especially learning about reductions and how reductions work is really key to understanding the whole idea of getting these things to work in a more functional style. So it's a lot about learning the basics of how to use this. And once you get it, it does make it really a lot easier. And the code in terms of the chaining together method calls, once you get the full stop at the beginning of the line rather than the end of the line, which is something that I used to do, also makes it a lot easier to actually read what's actually happening in your code.
This is really interesting because this reminds me of something which I think Oleg and you discussed on the speaker interviews afterwards. A blog that you wrote which had both imperative and functional code, and I think it randomly showed, once you hit the page, it randomly showed you one, and it timed how long. It was basically a question with a multiple-choice answer. And multiple choice answer, should I say? And you had to choose which answer you think was right for the question. The question was the same, but you had an imperative choice and you had a functional choice. Right. What were the results from that?
So this was very interesting. One we found was it took 30 seconds less. So people, when they came to the site, they were shown one or the other, and there were about 1,400 people who took the survey, and we found that about 30 seconds less for a correct response to functional style compared to imperative style. On the other hand, A few more people got it wrong for the functional style than imperative, but surprisingly, people who got the imperative style wrong took way too much time to get it wrong. So the point is, if you're going to fail, you rather fail fast. But one of the things I wanted to really make is you're thinking about two things, right? One is the ease and fluency of readability, and the ease and fluency of writability. And one of the things that catches me really well into functional style is readability is very high once you cross a little barrier. But writability is much more difficult. And the reason for that is when you look at a functional style code, it's intuitive, you can read it, you can understand it. But the ability to write that code in functional style, it takes a lot longer. Because we are ingrained, every one of us, me included, we have spent decades writing code in imperative style. Writing that code in functional style is really hard. But when somebody shows a functional style code, it's easier to read. So I think readability is much more faster. Writability takes a little longer.
And that's great. That's really great because it's so hard to read other people's code half the time.
Yeah.
So, cool. I'm going to jump.
Venkat, you're a guy that kind of has this good ideas of how people can actually learn this stuff. So what would be like a suggestion that you give for developers so they can learn better how to write functional code?
So one of my recommendations has been, I'm a huge fan of this mantra called make it work, make it better real soon. So when you're interested in writing functional style code, don't force it on yourself. Write it first in imperative style. Make it work, write automated test. The test tells you the code is working. Now start putting time into refactoring it. And the first few times it's going to be really hard. And normally what I recommend is take it to your colleague, and I'm a huge fan of this concept of rubber ducking. So I don't know how to get something working. I come to Simon and say, hey, Simon, I'm trying to get this working. Let me explain what I'm doing. And it snaps in right away, right? So we begin to learn very quickly when we try to explain to somebody else. And over the next few months to few years, and yeah, it does take time, we get really proficient. So right now I think I'm at about 50% level. Given a problem, 50% of the time I can write in functional style. The other 50% of the time I'm going to struggle for maybe a few minutes to a few hours, but that's okay. There's nothing wrong with it. And then I think we get better at it. So we get better by doing it. So seek help. Have somebody review the code. Try to explain to somebody else, and oftentimes you find the solution when you're trying to explain to people. That's really a better way to learn, in my opinion.
Okay, cool. I'm going to ask another question. We're going to jump over to still Java 8, but Java EE now. Bruno, are you a Java EE guy? I can't remember.
Yeah, a little bit. I haven't wrote Java EE for a while, but that's fine.
For some reason, when I ask, are you a Java EE guy, I really feel like I might be insulting someone for some reason. Okay, I'll ask.
Once you start doing containers and things in the cloud, then it's a lot easier to do smaller stuff.
So this is it's mostly Java EE though. Sorry, Java 8. So this is Blue61 asking an IRC. When will Java EE be in alignment with the functional style, or will it ever be? And the example that's being given is entity beans not being immutable, binders not returning streams. Do you think these features will at least partly be done sometime? And from a community point of view, is it being called for too much these days for Java EE?
So we're right now on the discussion of Java EE 8, right? So usually Java EE only addresses the new things on Java language and everything. Sometime after those things come out, of course, because Java EE comes after, sometimes some years after a new release of Java. So yes, those things are being discussed. Java EE 8 is in discussion right now, but there's lots of things undefined. And the way the process and the JCP process works is that there's a lot of people sending feedback and a lot of people kind of suggesting what things need to get into or not in Java EE 8. And right now there's still not a consensus of what exactly will be on Java EE 8, right? So yes, I think we can expect a few of those things starting to show up. But I'm not sure if we're going to do like a total revamp of Java EE APIs and everything on Lambda on this first initiative. So it might be something for Java EE 9 though. That's my impression.
Is this an example of standards not working, whereby we have something that's coming which is really, really great, like lambdas and streams, but we have to wait maybe a year or 2 years before we get it in a specification, then another couple of years before vendors start adding it into their app servers, then another year before you actually get your application rebased on that application server, and although we have, and by that time, Java is at the end of life. Is this a case of standards losing?
Well, I think it's. Oh, go ahead.
I was going to say, I don't think standards losing. It's just the fact that you've got two different standards. You've got Java SE, you've got Java EE, and they're on different timelines. So they come out at different times, and they have different cadence. So the problem is that you can't. It'd be very difficult to synchronize them, so that you've got like SE coming out at the same time as EE. That would require a lot of political will to do that.
But there must.
Yeah, that would delay Java SE for a long time, I guess.
but surely we're not talking about a huge amount of time to get simple things like, the example here was streams from a Finder. We're not talking. There's no reason why this needs to take that long. Huh?
Well, EE is a big specification, you see. So it's more that SE would be held up by EE rather than the other way around.
Right.
Let me jump in here a little. Simon, may I? I think the question is, in order to adopt Java SE 8 features, Java EE would have to break away from old platforms. And so if you're going to depend on new language features and new APIs in Java SE 8, you have to break away from Java SE 7. And so ultimately that's for the Java EE community to decide. And I don't know that part of the community very well. So, they've made statements like Java EE 8 will have alignment with Java SE 8, and then they talk about using lambdas and things like that. But what that means, though, is that if you have a deployment on Java 7, then you won't be able to move to Java EE 8 because it might require Java SE 8, and that's a big step. And so I think it's completely unrealistic for anybody to expect that they will come out at the same time. So you would expect there to be some time gap. And the question is, how long it takes for those standards to emerge, and how long. It's one thing to embrace new technology, but it's another thing to leave an old thing behind. And so, since they're large commercial customers that have many deployments and large investments in earlier Java releases, then they need that time to make that transition.
Okay, and this is going to be.
And I think Java EE has a difference. There's a little difficulty in this in moving extremely fast because Java EE is a standard for large projects, large corporations, and it takes some time for those customers to actually move to try new features and things like that. So the time frames for those two things, for Java SE and Java EE, are totally different, as Stuart said. And I think that the corporations that use Java EE, they do require some time for things to stabilize and for things to be proven before they are adopted widely, right? So I think we have to understand that Java it's technology that's used by all types of users. There is like the fast-moving, bleeding edge type of developer that can that can have every commit for OpenJDK they can start using immediately, right? But there is also a large number of companies and developers that are doing long-term systems that don't get redone or frequently and things like that, and there must be an effort to accommodate the needs for those guys. So I think Java EE is more focused on that area, and it's not going to be the bleeding edge. And I don't think that's standard solutions. I think actually it's actually the opposite. The fact that you have all those huge mass of general users adopting Java it actually shows that standards work and are really, really well on this situation.
Okay, let's jump to Jigsaw. It was always going to happen. It's happening now. We're going to talk about Jigsaw in Java 9. This is Wes Rees. What is Jigsaw going to mean for how we as application developers write our applications? Stuart?
Well, that's sort of tough to begin with. Maybe not much, because Jigsaw is a structuring mechanism for large systems. And unlike Lambda, where you can say, oh, okay, so I can take this for loop and rewrite it using Lambda, and within a few lines of code you can see a difference, right? That doesn't happen with Jigsaw. It's just a different kind of animal. Initially, I don't think there will be very much impact, because the JDK in JDK 9, the JDK itself will be modularized, but when you're running an application, you're going to put jars in your class path, and your application is probably going to be in a jar as well. So initially, you're going to continue to run in that style, and there probably won't be that much impact. Although I think that some changes in the JDK might impact some applications. So over the years, I think there's this a lot of leakage of JDK internal APIs has occurred, in particular things like sun.misc, and so those are going to be rearranged. Many of the little used ones are simply going away. Some of the ones that we would like to make, some of them that are internal, that are definitely internal APIs, but nonetheless have widespread use, in particular Sun Misc unsafe, are going to be rearranged so that they're put in a place where they fit more gracefully with the JDK's module system, and so libraries and applications will need to adapt to that. So there will be some migration effort involved. So I think that's kind of the early phase of modularization. Later on, if you decide to modularize your application, there's some additional work and benefits for doing that, but that's kind of more speculative. So you look like you want to push this in a different direction, Simon. So I'll turn back to you.
I was just going to comment that the good doctor isn't going to deprecate anything like unsafe without good community input and.
Well, there's been lots of community input, but in fact, Sun Misc unsafe has been deprecated for years, and nobody's paid attention to that anyway. So.
Well, it's never been a public API either, but people use it, right?
Okay,
right. Yes.
I've got to jump in here. There's a couple of things to say here. The first is, and agreeing with Stuart, yeah, that there's a clue in the name, unsafe.
No, sorry, that just makes it more exciting to use.
Yeah. But I think from a programming perspective, from a language level, there's not really much that will change under Jigsaw, because the idea is it's a module system. The thing that might be applicable in terms of at a language level when you're actually writing things is that visibility will change. And so public isn't necessarily going to mean public in the way that it has before. I think that's the biggest thing that people need to get used to, because you can have a module which contains public classes with public methods and public variables, but they don't actually have to be public outside of that module. So you won't have the same visibility that you have before, and you'll need to understand that if you're writing code using the module system. So I think that's probably the biggest thing that people will have to get used to. And then obviously if you want to modularize your application, you've got to start writing modulinfo.java files and figuring out what the dependencies are between your different modules and so on.
And this is starting to smell very much like OSGI.
Yeah. Let me just disagree a little bit here. I totally agree with everything you guys said about not impact much the way people develop applications, but I think Jigsaw will allow the Java VM to go easier on smaller devices, because the VM is going to be smaller, use less memory, will be more modular and everything like that. And I think that will allow Java to reach places that we to reach a huge industry that's coming out right now. There is the Internet of Things, right? So I'm looking forward for Jigsaw, not necessarily for how I'm going to change my application, but how it will allow the Java VM to run on all sorts of other places and in a much easier way. So I'm looking forward for that part.
So, Venkat, two questions then. First of all, on the back of that, do you think Java is the right tool to use for IoT?
It certainly is for a lot of reasons, because definitely Java as a platform is extremely capable, and absolutely, I think it is.
Mm-hmm. Second question, going back to the Jigsaw OSGI comment, M. Kalkov asks a question, will Project Jigsaw replace or complement OSGI? Sounds like it might complement to start off with, at least.
Well, I don't think it is necessarily going to complement. I wouldn't expect to use both of them together. But to combine this with the original question, I would say it's not going to make any impact on application development if you have never seen or faced a problem of it depends on, will it have an impact? The short answer to that is depends on what kind of applications you are developing. Mm-hmm. I've come across clients where, going back to what Bruno was saying, not just the size of the deployables on a device, but when you are trying to put things on a device and you upgrade one software and that completely rips out something else. Mm-hmm. I've seen this among people doing mobile device applications, people doing devices, applications on embedded devices. This is where you don't have the luxury of completely separating the class path, for example. And so one of the places where this can have a very huge impact is when you really want to modularize things so that applications or parts of applications don't step on each other's toe, it can have a huge impact. So I think the short answer is it has either no impact at all or it has a huge impact, really depending on the types of applications you're developing. OSGI has been used in some of these devices for a long time. And surely I think Java 9 modularity can replace some of those. I can't quite imagine how it can complement in that sense.
Okay. We're going to change direction slightly now, and we're going to talk about generics. So
maybe not.
Say?
Maybe not.
Yeah. I'll talk about it gently. So Jan Kim asks, this is on the forum, what are the chances of getting fully fledged generics in Java, i.e. moving beyond the Eurasia clunge? Kludge, sorry.
Kludge. It's a technical term. All right.
Take me out this hole, Stuart.
So really, I think that the disadvantages of erasure have been overstated. In most programming, it doesn't come up that often. Really, I think people complain a lot about generics because they're complex, and regardless of erasure or whether they had been reified, if you deal with wildcards, for instance, it's confusing and difficult to understand, and so there are lots of complaints about that. And reification will not fix those. In fact, so actually, little background. All right, so in the beginning there were raw types. You put something into a list, you had to get something out of a list. What came out of a list was an object, and you had to cast it into its right type. And so in Java 5, generics were added so that you didn't have to do the casting explicitly anymore. In fact, the compiler did it for you under the covers. But erasure refers to the fact that the generic type system is known only to the Java-C compiler. The JVM itself knows nothing of generics. And so that was done, as the questioner mentions, that was done for migration compatibility with raw types. And so actually, let me open this as a quick digression. So 10 years on, does anybody still use raw types? Well, I don't know. Most of the large libraries have been generified, but my hunch is that there's lots of dusty old code lying around in people's repositories that still uses raw types, and it would still be a huge migration problem if we took away raw types. So what that tells me is, if we were to go ahead and reify generics in a future version of JDK, we would have to provide, for instance, a set of erased collections as well as a set of reified collections. Okay, so that's adding complexity there because, oh, and actually another reason for erasure, continued support for erasure, is to support JVM languages, such as Python, Ruby, Scala, and so forth. They take advantage of the fact that generics are not enforced by the JVM because they implement their own generic type system. In fact, Scala has its own generic type system that differs in semantics from Java's type system. So if we reified Java's generic type system in the JVM, you would still need to be able to opt into it. So that means we have an erased generic type system and a reified generic type system going on in the same system. So that adds a lot of complexity, and in fact, not to much benefit. It cleans up some corner cases like allocating a generic array, but really, it doesn't buy you that much. What really so basically, the bottom line is, we've spent a lot of time investigating reifying generics and came to the conclusion that, yeah, it could be done, but the cost and complexity do not justify the benefits in doing so. But we're doing something different instead, which is what we're calling generic specialization, or in fact, it's a partial reification of generics to do things that were not possible before. And so this is part of the Valhalla value types work. One of the weaknesses with the generic type system in Java is that you cannot generify over primitives. So you can have an array list, you can have a list of integer, but you cannot have a list of int. And so the value types work is forcing that question. We want people to create their own value types which are similar to primitives in that they do not have identity. So if you create your own value type v, you want to be able to have a list of v, and in order to do that, we need to also figure out how to make a list of primitives, like list of int or list of byte or things like that. And so that's sort of a partial reification. In fact, the implementation choice is that, for instance, list of int will actually be reified in that it is known to the VM. It is actually a different type from a list of a reference type, which is what we have today. So that's really where the work in the generic type system and the JVM is going, which is in support of Valhalla, value types, and also this unification of the generic type system to support primitives and value types. And that provides a huge amount of value, right? So if you think of, if you've ever had to store integer, if you've ever had to cringe whenever you stored integers into a list, it's like, oh, maybe I should use an array instead. Oh, but then I have to deal with an array instead of in a list, right? So in Valhalla, you will be able to have things like lists, maps, sets, and whatnot of primitives like int and double and byte and so forth, and that's where that's where we're putting our effort, and that will have a huge benefit. So that's the choice we made, not just redefining generics over references.
So I totally agree. Value types is the kind of future for that. So we're getting that in Java 9, right?
No, the Valhalla stuff is coming after Java 9.
Oh, really?
Java 10 maybe, yeah.
Yeah,
I know. It's
so valuable to developers. Bruno, sorry, you were going to say something.
No, so Stuart, thanks a lot for this this story context and everything, because I think it's really nice to see what things the VM guys have to go through and the library guys have to go through to keep one thing that's amazingly important for Java, that is the backwards compatibility, and it's a pain, right? And a lot of people don't realize how much work is being done to keep that thing. It's one of the main tenets that keep Java relevant, right? And I think that you guys are doing a lot of work to make that stuff happen. And I love to hear these little stories and these little decisions that go in the background that just kind of leak through how much work the backward compatibility is and how important it is for all of us. So thanks.
All right. Thank you.
Well said. Let's jump over to shells. So Kedar asks in the forum, will there be a great shell for Java that comes by default for JRE-JDK? I'm guessing referring to JShell, perhaps. PM771 asks, what was the drive behind JShell? What kind of urgent need does it fill? Venkat, are you a shell person, a REPL kind of person?
I would say any language worth its salt needs to have a REPL.
Okay.
This goes back way back in time.
So Java, in the last 20 years, Java hasn't been worth its salt.
Well, not for this particular reason.
Okay.
And I would say, this goes back to time when I was programming in C++, decades ago. I would write code in C++, and you know how you treated VB and VB programmers, but when I write C++, at times for quick feedback loops, I would turn the computer away from the window, bring up VB, because in VB you can dynamically interact with C++ code, and this is like your code comes to life. So one of the things I do quite often when I program in Groovy and Rails, Scala, just about any language, including Haskell for that matter, is one of the key things for us to do. IDEs are great. And when you go to an IDE, you put a little dot, and then it shows you a beautiful set of functions. Well, but what's really missing here is the live interactive experimentation. So to me, programming is a series of experimentation. You have a thought, hey, would this work? Well, I don't want to wait until I write the code, even run a unit test to get the feedback. In fact, to me, if I can bring up a shell, type in a few lines of code, make sure it's actually working, and then use this beautiful tool called copy and pasting. And you can copy and paste the code from the shell all the way to your code and run the unit test. To me, that's a really powerful model. And I'm a huge fan. Almost in any language that has a REPL, I constantly use a REPL.
I think you can export all your commands that you call in a REPL as well, direct to a script that you can actually run.
Absolutely. And guess what? The REPLs give you this kind of intelligence as well. If you go into a REPL, you put a dot and hit the tab, and it tells you what you can drive. So I can't live without REPL. And so yeah, absolutely, I'm dying to have this.
Okay, so Stuart, what was the, to answer PMM771's question, what was the drive, what was the urgent need that REPL fills over and above, let's say, I don't know, value types?
Well, it's hard to make a direct comparison between things that are different. I think it's people have missed having a.
You kind of can because it's resource, right? A team of developers have to produce a certain amount of code in a release. They work on one thing or another.
Well, yeah, well, but yes and no, right? Because the fact is we have a bunch of different people on the team with different skills, and they work on different things, right? So there was some stupid internet discussion, a couple months ago about, value types are so important. They should put everybody on value types. Well, that would actually slow it down. So, people work on different things. I think there's this fallacy in project management, which is everybody has to work on the priority one thing and nothing else gets done until that's done. The fact is we're working on a bunch of different things that are all important. They are mostly more important than the things we are not working on. But it's hard to say, should you do this and that, because we're doing a lot of different things at the same time. So anyway, so the first question was, will there be a great shell for Java? And in fact, yes, there will be. JShell is in JDK 9. A bit of background is that this uses the compiler API, which is different from other shells that have existed, which re-implemented the parsing and semantic analysis of Java expressions. This uses the real compiler API, so you get the same level of type inference and the same exact semantics as you get from compiling that code as you do when you type it into the shell. So that's a big advantage. So what's the driving impetus? I think it was. I think Venkat said some things that were very important. I echo his need and desire to have a REPL. It's very, very useful. But also, it's helpful for learnability. Because if you think about somebody who's learning Java, if you open up JShell for the first time, you can just type an expression and it evaluates it for you and shows the result, which is a very immediate feedback for beginners as well as for experts. And so if you think about how much you have to learn as a beginning Java program, suppose you're a beginning programmer. if you haven't learned any other programming language, in order to print hello world, okay, well, let's see. First, there are import lines, and then there's public class hello, public static void main, right? So if you're an instructor, that's a lot of explaining you have to do before you even get to the print statement. And in fact, the print statement is spelled system.out.println, which is quite a mouthful as well. So there's a lot that you have to do before you even get to hello world. And so with the REPL, it opens up a whole new possibilities for learning, both for beginners and for experts. And I actually want to tell a little story here, which echoes what Venkat said, which is, so I use NetBeans as my IDE, and it's very nice to be able to type stuff and do code completion, get immediate feedback for syntax errors and type errors and whatnot. But still, even though I do that, for experimenting and trying stuff out, I switch over to the REPL. And the reason is it just supports a different style of exploring space of getting your problem solved. Sometimes you try a bunch of stuff out and you get very deep in an exploration. You're getting results. You're not getting syntax errors or type errors or anything like that. But you're building up an expression with some results, and the REPL saves all of those intermediate values for you. And so you chart this path, this complicated path through the solution space, and you say, oh, this is what I want to do. And so what you can do is, it's much easier to do that in a REPL than in an IDE. Because in an IDE, in order to run it, you have to start with the main program and do something. And so when I've done this in an IDE, I'm constantly commenting out and uncommenting things, and I'm confusing myself about what I tried and what I haven't tried. But in REPL, I can scroll back and say, oh yeah, I tried this. Oh, that was a dead end. I'm going to try something else. And I can pull in various bits and say, aha, this is my solution here from scrolling back in the history of the REPL. So it's a different kind of programming. It's useful for beginners and experts, and so I think it's really cool.
Okay. Stuart, you might want to just unplug and replug your mic and just make a little bit of noise just towards the end there. But let's move over to Simon. Let's talk about optionals. So obviously, when things like lambdas and streams and so forth were added, we were able to use the default methods to add extra things to our existing APIs, existing collections interfaces to use lambdas in our collections. Why wasn't the same done for optionals, and do you think that is something that we need?
Okay, I'm not quite sure I understand the question. So we've got optionals, yeah?
So, yeah, do you think we'll ever use them in our collection APIs?
Oh, I see. Optionals in a collection API.
So returning an optional, for example, what I'm getting from the question.
But isn't that happening, for example, when you do a find first? You are getting optional already.
Yep. Yeah, I mean, the streams uses them in terms of returning, like, if you've got something where you try to do like a maximum or a minimum of like a collection and there's no values in the collection, it doesn't make any sense, so you get an optional. But actually storing an optional in a collection, I mean, you could do that if you wanted to. There's nothing to stop you doing that.
Okay.
Maybe there should be something that's not
maybe I'm kind of missing the point of the question, but
okay.
One of the interesting things about optional is in JDK 9 that they're introducing so you can do a stream from an optional, which gives you a stream of 0 or 1 elements, which is kind of an interesting idea.
Short stream. Another question.
Simon, you jump in on the optional thing.
Your mic's got worse.
Real. Can you hear me now?
Not a bit like
it's almost like dark side. It's a very dark
maybe on that. Yeah.
Okay.
Oh, that's pretty cool. Keep talking like this.
Say, I am your father, Luke.
So we've only got actually a couple of minutes left. Just a couple of questions there. Let's talk about Swing and JavaFX. Blue61 is saying that a project that they work on, there are a large number, about 250 Swing J panels in use, and they want to migrate them to JavaFX. If I understand the deprecation of Swing correctly, will there be any supporting tools to migrate Swing panels to JavaFX, or maybe a generator to read layout manager data and output JFX layout data? it seemed mean to ask someone directly about that. So anyone?
Actually, I'll try and have a go at that one. I'm trying to remember because I know we did some stuff. I say we. I've got to stop saying we because it's not we anymore. They. Yeah, Oracle did some stuff in terms of migration. So you could integrate JavaFX components into a Swing layout. And there was also the ability to do it the other way around. So you could have a JavaFX layout, and then you could integrate Swing components into that. So that was the idea of a migration path. So you could either say, right, okay, start with a JavaFX layout, and then add, if you've got complex Swing components that you needed to add to that, you could do that. Or if you've got a very complex Swing layout and you wanted to gradually replace the components in that with JavaFX ones, you could do that as well. I can't answer the question about exactly what's going to happen, but I doubt that there will be any tools generated for that specifically unless it's by the community.
Is JavaFX complete enough to be able to say deprecate Swing and everyone who's using Swing to migrate across to JavaFX?
I'm gonna go out on a limb here and say yes, but I don't think that deprecating Swing would be the right thing to do. And the primary reason for that is because JavaFX is not part of the standard. So you can't really deprecate Swing at the moment because JavaFX is an external API. So it's not part of the standard. If JavaFX became part of the standard, then that might be a different discussion and you could potentially then deprecate Swing. But right now, with JavaFX not being part of the Java SE standard, I don't think you could do that.
So, Doctor, is Swing deprecated at the moment or not?
No, I have not heard any plans about deprecating Swing. So how's the sound quality now?
Much better.
Ah, good. Okay. Yeah. So I think I can't speak for the desktop guys. If anything were to be deprecated, it would be in AWT. Certainly, the modularization effort in Jigsaw has caused some things to be rearranged in AWT. In particular, removal of the peer interfaces. So peers are still under there in AWT, but the fact that there were peers leaked into the standard API, which was a mistake, and so that got cleaned up. But I don't know if there is a I don't know if there's a roadmap for deprecating desktop stuff. But if there were, it would start to be stuff in AWT. Oh, and of course, there's the applet and the Java plugin stuff is being deprecated in JDK 9 because that's the way the whole browser industry is moving away from plugins as well. So there you go.
Awesome. Okay, so we're 3 minutes over time, so we're going to finish up with 3 quick questions. So first of all, Showtime asks, when would you use Java 8 and when would you choose Scala? Venkat, I'll ask this one.
Well, so I think people who are using languages like Scala are going to continue to use it. I don't think it's going to be a migratory path. If at all, what I feel is the Java 8 coming up to providing function style programming, it gives a nice path for people to move from one to the other if they want to. It's not the question of haves and have-nots anymore. So it's really a question of preferences and choices. If I have a team which is developing deeply in Java, have a lot of investment in it, and if only I care about functional style of programming, I would use Java 8. If I have other concerns, like very heavy conciseness, concurrency libraries, XML transformations, and various other things, and if my team is capable of using something like Scala or Akka, then I would probably use Scala. So it's really a question of the team's capabilities, the project needs. So it's not a question of one versus the other anymore, in my opinion.
Second to last question. Keita says, I personally call Java 8 the biggest change to Java since Java. Does everyone agree with this? Does everyone foresee another version of Java in the near future that's gonna be as big a change, or do you think this is the biggest change in Java since?
I personally think that I agree with that.
Yeah.
Absolutely.
Yeah, I'd agree with that. I think value types are going to be another substantial change, but yeah, I think lambdas and streams is the biggest change since the beginning of the language.
I would actually say that Java 5 was a bigger change because of the changes to the type system, but Java 8 was definitely a big significant change. And value types in perhaps JDK 10 will be big too.
Yeah, and I like, I'm sorry I had to reboot here. My computer just crashed for some reason. But I'm on a cell phone now, so I hope you can hear me. And I actually think that invoke dynamics was a really important step. It's actually used invoke dynamics used to implement Lambda. And I think the invoke dynamics kind of created a new mindset on the JVM team by doing things for other languages to be on top of the Java VM, and that really impacted even the decision to implement Lambdas later on. So I kind of think that for me, although it was not a big change for developers, I think the biggest change that we had was around invoke dynamics. So,
which was in version 7, right, of the JVM?
7.
Java 7.
That's
yes,
right.
Java 7.
And one final question, then, a really, really important question, maybe more for Dr. Deprecator. From SidMaker, will we ever see a day where semicolons are end-of-life in Java?
There's nothing wrong with semicolons.
No, I think he meant end of line, or that's actually a statement terminator. But the fact is, in the REPL, you don't have to use semicolons. But in the compiled language, no, I don't see that happening.
Yeah, I think semicolons are a much maligned punctuation mark. I think that people should use them more in English as well.
Yeah, you seem quite attached to the semicolon then from your response, Simon.
Yes, I use semicolons.
Maybe just a distant friend.
Yeah, distant friend. Yes.
Yeah. Well, guys, it's been a really good session. I've really enjoyed it. I must say thank you very much, certainly to Venkat for coming all the way to Colorado to my house to give the session, just for the session, right? And I think you're doing a bit of work on the side as well while you're here. That's really, really great. Thank you, Stuart. Thank you, Simon. Thank you, Bruno in particular, actually, for joining us on very short notice for this panel. Thanks again to everyone who asked their questions. We couldn't get through them all. There were a lot of questions, a lot of even pre-asked questions that we couldn't get through. So yeah, I hope you guys all had fun on the.
Simon, I did answer a few questions that you didn't ask. So Simon, I did answer a few questions that you didn't ask. I answered on the forum. So if people want to go check there, that's fine.
That's a great point. Yeah. So what I'll do is when we write this up, we'll point a link to that forum, and if anyone actually on the panel or on the VJob as members wanted to add their own comments or answers onto that forum, they're more than welcome to, of course. So yeah, thanks very much, everyone. Our next session, yay! I don't normally get a round of applause in live. I normally I hear it muted across the virtual chat. So our next session is tomorrow, and that is a Java EE book reading club, back to the normal time of 5 p.m. GMT, and that's a book reading club around Java EE. With Antonio Goncalves from Paris. So do feel free to join that. It's actually going to be a very similar kind of feel to this kind of session where it's very interactive and Q&A based. Any final points from anyone before we say good night to people, or good morning? Thanks for making this happen. My pleasure, man. It's good. Great, thank you very much. Have a good evening and a good day to everyone wherever you are, and see you next time on the VJob.
Thank you.
All right.
Okay. Thanks, everyone. Thanks a lot. Thanks for the opportunity. Thanks for everyone that's watching. See you.
Bye.